Hi, your next challenge is entitled Count the Number of Duplicate Characters. Create a function that takes a string and returns the number of alphanumeric characters that occur more than once. So, we'll start with the notes here. It says that duplicate characters are case sensitive, good to know, and the input string will contain only alphanumeric characters. Now we can go to the examples and figure out what they're saying. Notice A, B, C, D, E is all unique characters, so we return 0. But in the second example, we have 2 A's and 2 B's, and then the C, D, E from the previous example. We return 2 because A has more than one character, and B has more than one character. So there are 2 characters that are repeated. Example 3 shows indivisibilities. So clearly the letter I is repeated, and then there's also one with the letter S, and that gives you your result of 2. And the final example highlights the case sensitivity comment, where you have an uppercase and a lowercase a, but they don't match, so you return 0. I think that's pretty clear now. We'll head over to code. Please pause the video and give this an honest attempt, and come back when you're ready. I'm going to introduce a new data structure for this solution, which is good. It's a lot like the one we learned recently called hash set. This one is a full-fledged dictionary. It's like a hash set in that, with the exception now that we have a key and a value. With the hash set, the value kind of acted like the key as well. And a good analogy for a dictionary is a phone book. So you can think of a key being a person's name and a value being the associated phone number, telephone number for that person. That's a nice real-world example. You can look up the documentation. I recommend that to see what you have available with it. Very simply, it says represents a collection of keys and values. That is the very basic description of it. There's one tiny section I don't like to read to you guys because I know you can read, but there was a tiny section I wanted to read just to emphasize it. In the remarks section, the dictionary generic class provides a mapping from a set of keys to a set of values. Each addition to the dictionary consists of a value and its associated key. So that's good to know. When we add to this collection, we're providing both a value and its associated key. Retrieving a value by using its key is very fast, close to constant time, which is big O of 1, because the dictionary class is implemented as a hash table, and we talked a little bit about hashing with the hash set. Basically what this does is, regardless of what type you put in as a key, it may be a string or something, we know that it's generic, it can be anything, but the hash function underneath will run a method based on your key, and its job is, whatever the kind is, it will generate an integer value that can be used to index into the collection. And so we've seen with arrays that they're really fast. You have random access. You can say, go to array index 12 or 20 or 2. You can go wherever you want with those indexes. And so the hash system is sort of like that. It takes your object and converts it into an integer that's made within the range of the collection size, and you essentially then are accessing it in the same way as an integer into an array. Your key becomes performant like that, with the idea that the hash function that transforms it is reasonably fast. And you get an integer value that represents its index location very quickly. So dictionaries are very cool, and we'll use one here. I think it'll work for us. So if you didn't notice, on the dictionary page, we're going to need that system collections generic statement for that data type. Let's get that out of the way. System collections generic. And this will allow us to make a dictionary. And we can do that to start. We'll say dictionary. And remember, it had 2 generic types. The first one representing the key. Think of a name in a phone book. And the second, a value. Think of a phone number in a phone book. In our case, what I'm doing is I'm making character counts of the string. We're going to process the whole string, examine each character, and make a count associated with it. When I'm done iterating over the entire string, then I'll have this dictionary of character counts that will map each character to the number of times it occurs in the string. And then at the end I can simply return the count of dictionary elements that are greater than 1. So we'll say char, we know that string is a collection of characters, and then int for the character count. And you want to name it appropriately. And then we're going to create an object of this dictionary type. So you say new dictionary, give it the matching generic types, like that. So now we have an instance of a dictionary. It's important to create it with this new statement right here. Now we have a dictionary that's initialized. If we had just killed this off with a semicolon, it would be uninitialized, and when you go to use it, you're going to crash out. So, very important. Initialize that. At this point, we can go through our collection. For each char, we'll call it, it was alphanumeric characters, so I don't think it has to be letters, so I'll just use the CH that we normally use for characters then. Alright, this will go through every character in the string, right? Now we're going to check if char counts, let's call it char counts, it's more than 1. If char counts contains, you'll see in the documentation that there's a contains method that will look up if an element is contained for you. If it contains, went double R there. I'm going to start with the case where it's not present already. If it's not present in our dictionary, this is our first time encountering the character, and we need to add it to the dictionary. So you could say char counts, add, and then remember it's 2 values this time. You have to add a key and an associated value. So we're going to add the character, and if this is the first time it's being encountered, its count would be 1, right? Good. Otherwise, that means the char count is contained, right? We said if it doesn't contain it, do this. So in this else clause now, that means the letter or the character is already in the dictionary. In that case, we simply want to increment its count. So you could say char counts with the key, which is the key. The character is the key. And you can increment it because it's an integer, right? We said the value is an integer, so we can use this plus plus increment operator. And this will boost the count up for that character by 1. And then after this loop, you've already gone through all characters in the string. You've loaded up your dictionary with characters and counts. Now we can say return char counts. And I'm going to use a link method here to count, and then I can give it a lambda. If you don't remember count from link, feel free to look that method up for the enumerable class. You could search for C# enumerable count, and that will get you where you need to be. And then think of our lambda here, right? So our argument, what is char counts? It's a collection of these character to integers, and these are also known as key value pairs, right? It's a key and a value in a pair, so it's common to refer to them that way. So I'm going to name my variable name KVP for short, key value pair. And remember, it's going through this dictionary. Each element is a dictionary entry, which is a key value pair. So for that, I could say KVP. A dictionary entry has a key property and a value property. I'm accessing the value, which is the character count, not the character itself. I don't care what the character is. I want to see any count that is greater than 1. So count it. This is saying count the entry if its value, the integer, is greater than 1. That means it's repeated, right? It's exactly what they told us to do. And then for this count method, we have to bring in system link. Don't be confused by this. I believe the dictionary has a count property that will tell you the number of values in the dictionary. It'll tell you how many key value pairs are in there. But this is a method call. See these parentheses with the lambda statement in here? So this is invoking the link method. Had I not brought link in, it probably would have said I was trying to call this property as a method or something like that. But yeah, this is different than the dictionary's count property. Remember, look at the properties. See, dictionary has a count that will tell you how many. That's not what that is. We're using a method there. And you can look at some of the other methods you get with the dictionary that we used. Add, contains we used. I think I actually wrote that wrong. We'll have to change ours to contains key. So I'm glad I looked at that. Let's fix our contains. Contains key. The character is a key, right? So that spared us an error. Otherwise, I think this looks good. Let's run the check. See what happens. Great, all tests pass. So yeah, there's your new data structure. It's a very powerful one. I encourage you to work with it and to use it. General strategy: break the string down into character counts, go through all the characters, load up the dictionary, increment the character count as we encounter each character. If it isn't present, make an entry for it and then add to it. And finally, just count however many entries in the dictionary have a value greater than 1, just like they asked us. So yeah, pretty simple algorithm there. If you came up with something different, let's see it. Otherwise, let's keep marching to the next challenge. Thanks for watching.